In this video, we will be creating a custom shape locator which would have a shape of a footprint and it would have a text left foot on it. This text will always be facing towards the camera irrespective to what view you are in. It would always face towards you. So this kind of custom locator is useful for the rigging purposes, where to control the rig you just have the curves because they are not rendered in the scene, but they are sometimes difficult to see. Using these custom locators, you can draw the complex shapes and treat them as the other shape inside the scene, but they will not be rendered when you will render your scene or the frames. So in this way, you can create the complete set of left foot, right foot, hand, head, eyes, mustache, and beard, and whatever accessory you want. And you can create the complete library of these custom locators and provide it to the riggers. So that's what we will be developing or building in this video tutorial. Any shape that defines a point in a 3D space and which is not renderable is called as locator in Maya. Normally we know about this three-dimensional plus sign as locator because that's the standard locator provided by Maya, but we can also create our custom shapes for the locators. And that's what we are going to learn in this video. There are three things to consider when we are drawing a locator. First, draw or define a shape of the locator. So what kind of custom locator do you want to draw? What is the shape of it? Second, we will define, does it have a bounding box? That is an optional step, but to operate on your locator properly, to let Maya know that what is the size of the locator, what is the bounding box of your locator, so that it can focus on your locator properly, it can align it in the camera view properly, you would have to define the bounding box of your locator. If you create a locator which is 10 units long, 10 units wide, or 100 units long, 100 units wide, and if you would try to focus your locator in the camera view of the Maya, it might not focus it properly unless you define the bounding box of your locator. So to perform the camera operations properly, we will have to define a bounding box of the locator. And after defining that it has a bounding box or not, we will define the size of the bounding box. After understanding these three steps, we know that what to do. And now we will understand how we can do this. So the first point is define a shape or drawing a shape. To draw the shape of locator, we will be using OpenGL functions. And to do so, we will use a class that provides the wrappers for the basic OpenGL API functions. And the class is MGL function table. We will be using MGL function table class to define or to use these OpenGL functions to draw our locator. And to use this class, we will not instantiate this class. Instead, we will grab a pointer which is already existing in your Maya instance. Now, we know that how to perform the first step. Second step, to define if it has a bounding box or not. To define that, we will use a function which is called as isBounded. And after that, to define the bounding box, we will use a function bounding box. And to draw the shape of the locator, we would first have to create a locator node inside Maya. And how we will create this locator node? Locator node is very similar to other nodes, other DAG nodes in Maya. It would be similar to the way we created our custom node. And to create the locator node, we will use a class of Maya Python API or Maya API, which is mpx locator node. Using this class, we will create a locator node, and then we will use the functions that come with the locator node. So we saw that we would have to perform 3 functions: draw, and for that, for drawing the shape of locator, we get draw function with the mpx locator node. Second, to check if it has a bounding box or not, we get a function is bounded. And to define the bounding box, we get a function bounding box. And to define our custom shape and the bounding box, we would override these functions that come with the mpx locator node or the locator node. And we will write our own code to draw and define the bounding box. So we discussed that we will be using MGL function table class, which provides the wrappers for the basic OpenGL API function. Instead, we will be getting the pointer of this class, which is already instantiated in your Maya instance. And how we will get the pointer? We will grab the pointer of this class using a class mHardwareRenderer. This class provides the functionality of the hardware renderer. So using this hardware renderer, we will grab the pointer of MGL function table, and then we will start using our OpenGL functions. mHardwareRenderer is the part of OpenMayaRender. So first we will use OpenMayaRender, and then we will use mHardwareRenderer. And because we cannot create MGL function table on our own, we would have to grab it through the hardware renderer. We would first grab the pointer of our hardware renderer, and we will use a function called as the renderer. This will give us the pointer to the hardware renderer. After getting this link of our hardware renderer, we will grab the link of our function table, or we will grab the pointer of our function table. And how we will do that? We will use a function called as GL function table. And as soon as we have the pointer of our function table, we can start performing OpenGL functions. So that is what we are going to use in our code. And now we will go to Maya and write the code for our custom locator. So we are in our Maya environment now. And first of all, we will do our usual thing of importing the classes. So I would start importing the classes. After importing these three classes, I would import one more class, which is OpenMayaRender, and we saw that why we need this class. We need this class to grab mHardwareRender, which eventually would give us the pointer to our hardware render, through which we will grab the pointer of GL function table. After this, what I would do is I would grab my wheel node code, which we wrote in the custom node video, and I will copy node creator, node initializer, initialize plugin, and uninitialize plugin functions and paste it in our script editor. And after that, I would start making the changes. First, I would clear out my node initializer function, or instead of deleting everything, I would delete 2 attributes. I would just leave 1. Okay. And I will also delete the comments just to keep the code cleaner. If you want to keep it, you can leave them. But just to make it concise, I will just delete those comments. So we have our node creator function, and we will change the name of the class because we will create our own class. And in the initialize plugin, we would also define what type of node it is, which is OpenMaya mpx node dot k locator node, because locator nodes are k locator node type nodes. Okay. Now I will copy 2 more variables, which are node name and node ID, and paste them in our script editor. After that, I would start defining my class, and I would name my class as locator node. So when we were creating our custom nodes, we were using our mpx node class, and for creating the locator nodes, we will use mpx locator node class. So I would inherit that class OpenMaya mpx dot mpx locator node. After inheriting the class, I would create a constructor. Pass self to it, and then I would initialize OpenMaya mpx dot mpx locator dot underscore underscore init underscore underscore and pass self to it. So we are done with our constructor, and then we will get a compute function as well. Just to show you the structure of our locator node, I will take you to the API documentation, And here we see that mpx locator node is derived from mpx node, and we get isBounded function with it, bounding box function with it. And because this locator node is derived from mpx node, we will get a compute function as well, the way we got the compute function in our wheel node class. And because there is no computation involved with the locator nodes, we would override this function, and we would override it with no instructions. So whenever the compute function will be called, it would not be performing any operations or calculations. So we would use it in the way we used it in the previous videos. We will pass plug self data block. And after passing that, I would just return OpenMaya.k unknown parameter, and u is uppercase, so k unknown parameters. I'm not performing any computation. So our compute function is done here. And then we will write a draw function, because we will be drawing our custom shape. And we will first pass self to it, and then we will pass view. So whenever the draw function will be called to draw the custom shape of our custom locator, these arguments will be passed to the draw function. And the view is the 3D view in which we will be drawing our OpenGL shape. So after passing view, we will pass path, and this is the DAG path of your locator. After that, we would provide style. What is style? Style are the different modes of display we have in Maya. For example, it can be flat shaded, it can be wireframe, or points, or in the bounding box mode. So these are the different styles in which we are in. So if we are in wireframe and we want to see the wireframe of our custom shape, we will check which style our Maya is in currently, and based on that we will draw a different shape. However, we will not be doing the complex shapes in this video, but you can use the style to make your different shapes based on what style or what mode your Maya is in. And after that, we would provide status. And this is the status of the selection of your locator shape. So if your locator shape or your locator node is selected, the status will be different. If it is not selected, the status would be different. If it is selected with something else, the status would be different. And we will see how we can utilize the status. So after using or after defining those parameters of draw function, we will write the code for draw. But before that, we will grab the pointer to our function table so that we can start using it. So on top of our class, which is outside our class, I would use OpenMayaRender dot m hardware render dot the renderer. So I would save this, which would give me a link or the pointer to our hardware render, and using which I will grab a pointer to our GL function table, and GL renderer dot GL function table, and I will store that in glft. So to get the command completion, I will just execute them, and now we have the access to our GL function table. Now we will write our draw function, and for those who are familiar with the OpenGL, when we begin to draw something, we let OpenGL know that we are going to draw something using BeginGL. In the similar way, we would let our 3D view know that we are going to begin to draw something. So how we would let view, which is our 3D view, know that we are going to draw something using BeginGL function. One of the important thing about OpenGL that it is a state machine. That means it stores the states at specific time. And in short, the state is the value of different attributes at a certain point of time. So one important thing about this is we will preserve this OpenGL state before and after the execution of our draw function. So the state where we started our draw function, after the completion of our draw function, we will leave the state exactly at the same situation. To maintain the state of the OpenGL, we would use a function glft dot gl push attributes, and it would push certain attributes which are passed to this function. So it's a stack, and it would push those attributes inside that stack. And which attributes do we want to push? OpenMayaRender dot mgl underscore current bit. MGL current bit. And what is MGL current bit? MGL bit is a collection of certain attributes like RGBA colors, texture coordinates, raster position, etc. And if you want to learn more about the current bit, you can take a look at Microsoft's MSDN page. So these are the attributes that GL current bit contains. And because this is an OpenGL function, you can read more documentation about OpenGL, and you would know what is the functionality of different functions inside OpenGL. After pushing our current MGL current bit, we would perform one more thing, because we want to see, or we want to apply the alpha or the transparency on our custom shapes. So we would enable a mode inside OpenGL, and that mode is blend mode, which would enable us to blend the opacities or the pixels. So in short, this gives you the capability of applying the transparency on your shapes. So to enable that functionality or the mode, we would use GL enable. And what mode do we want to enable? OpenMayaRender dot mgl blend. So this would enable the blend mode. After enabling our blend mode, we will define the blend function. Using this function, we will define a usual technique of blending, and which is blend between the alpha of the source and it's 1 minus alpha. You can learn more about these techniques in OpenGL documentation, and if you want to see the results of the different techniques, you can take a look at Anders Rigelson's page, and there are different options you can use to see the different blends. So what we are going to use is GLSCR, which is the source alpha, and 1 minus source alpha. So this is the blend you will get, and if you would use any other technique, these are the results. So you can, just for the experimenting or playing with it, you can try using different techniques, but we will be using source alpha and 1 minus source alpha technique. So how we can define that technique? We will define that technique using GL function table, GL blend function, and we will define those two properties using which we want to apply our blending. OpenMayaRender dot mgl underscore source src underscore alpha, and second argument is OpenMayaRender dot mgl 1 minus source alpha. So here we have defined our blending function. So first we pushed the current state. After that we enabled blend mode. To enable the transparency, and then we defined our blend function. Okay. And after that we will pick the color in which we want to draw our custom shape. And we also discussed that in the different modes we want to pick different colors. Now we would use the status, which is passed to the draw function. If you want to see the list of different statuses, you can refer to OpenMaya or Maya API 2013 documentation, and if you go to the MPX locator node, you can find the list of all the statuses. The K active when the object is active, K dormant when your object is not selected, and there is K lead when you select your shape and then you select something else and then you select something else. So we will be using these three values to define three different colors for our custom locator. So here I will define, if my status is view.kActive, then my color would be something else. Else if my status is view.kLead, color would be something else. Else if status is K dormant when your shape or the locator is not selected. So first I would define the color when our locator node is selected. And we will use a function called as GL color 4F, because we are defining 4 float values to it. First is R, and I want to set R 0.2, 0.2, G B, and alpha. So this is my color when my node is selected. In the similar way, I will define a color when it is selected with something else, or when your shape is last selected object. And in the similar way, I will also define when it is not selected. And when it is not selected, I want to define it as gray. Okay, so we have defined our colors. And at this point, I will correct the name, node name. I want to give the node name as left foot because we are creating this locator for left foot. After that, I would also correct it. I will copy the name of my class and I would paste it inside the node creator function so that it can return the pointer to the instance of locator node class. Okay, so after picking up the color, we can begin drawing our shape. And to begin drawing our shape, we will use a function glft.gl begin. And after we are done drawing our shape, we will use a function gl end. So this lets OpenGL know that we are going to begin to draw something and then we are done drawing something. So here we are drawing something, draw a shape. And after completion of drawing of your shape, we would retain the state of the OpenGL. So the state where we left, at that point we pushed the current bit. And now we want to restore Maya in the same state. So for restoring at the same state, we will use glft.gl pop attribute because we pushed the attribute first and we would pop the attribute now and it would restore our state to the state which we pushed. And we also did one more thing here, that we enabled the blend mode. So before we pop or we restore the state, we will have to disable that blend mode. And to disable that, we will use gl disable. What do we want to disable? OpenMayaRender dot mgl underscore blend. So everything is in uppercase. So we have disabled our blend mode and then we have restored the state. Now we will also let our view know that we are done drawing, and to do that we will use endgl. The way we used it for the function table, we would use it for the 3D view as well. So our important drawing task is done, and I would clean up the node initializer function because we don't need any attribute for the locator node. Now we will see how to draw the shape which we want. And in this case, we want to draw a shape of a footprint or the shoe print. So first we will define what type of primitive we are going to draw, and then we will define the points of the primitive. So in our example, we will be drawing a polygon shape. And when we draw the polygon shape, we define the points of the polygon. So this is the shape we want. So first we want to draw a polygon, and then we will define the point position of all these vertices. And because these two parts are different polygon, we will have to define them separately. So in the GL begin, I will define I want to draw a polygon. And for that, I will use MGL underscore polygon. And in here, I will have to define the points, and I will define the points using the function GL vertex 3f, because I will be defining X, Y, and Z location. Now, I will have to get the points of my shape. So to get the points of my shape, what I usually do is I create a curve, and this curve would be linear curve, and I start drawing the shape close to the origin. And as soon as I press enter, it gives me all the point positions. And I will take those values and I would feed them in here. And after feeding them in here, it looks like this. And I will also correct these because it's equals to. Okay, so now we are in the good shape to at least test our custom locator shape, and then in the next pass we will add the second part of our shape, which is this second polygon. So let's get back to Maya and save the script, and I want to save it under C drive plugin, and I want to save it as locators.py. Okay, after saving that, I would load my script, and I will create the name, or I will create the node which we defined here. So first we will check if our script loads fine. So import maya.cmds load plugin. So it has loaded fine, and now we would create the shape. So we have created our custom locator here. And this is our shape. I have created a little bit tilted, so it has a slant tilt, and when it is selected it is red, when it is not selected it is gray, and when it is selected with something else, so if I select my locator and then I select my object, it's green. So using the status, we define 3 different colors to it. And that's where we define those 3 different colors, and that's our shape. In the next pass, we would define the second shape. So I will do the same thing which I did here. I would create a curve and grab the points from it, and I will draw another shape. Control C, draw a shape again. We want to keep the color scheme for this shape same, so we are not defining it again. We could have used a different scheme and we could have defined different colors for that, but we don't want to do it for this case. So I will grab the points which I got by creating a curve and paste them here, and this would create second shape of our shoe print. And the third thing is we also want to define a text. We want to make it look like a label, and for that we will use a function which is a 3D view function. So we will call view dot draw text. So this would draw a text for us. And what do we want to type here? We want to see left foot, and then we would define the location for it. OpenMaya dot m point, and I want to draw it at 0, 0, 0. And then we will define the alignment of the text, which is k left. So this would give us the text left foot at 0, 0, 0. Okay, let's save this. So I will save my script on the same location. And I will open the new instance of Maya and try loading my plugin and creating the node again. So I have opened the new session of Maya, and I will first load my plugin here and then create the node. And we have our text here and the complete shape, but we are not very happy with the alpha of the text. We don't want to see any transparency. We want to see our text as opaque. And to do that, I would modify our code a little bit. And before drawing the text here, we would define our color scheme again. And in this scheme, instead of 0.3 alpha, we would provide 1 alpha. So it would be completely opaque. I will save my script. Reopen session and reload the plugin. So now we have a full opaque text here, and it would always be facing towards the camera in all the views. So wherever you rotate the camera, it would always be facing towards the camera. So that is how we create the locators. And in this way, you can create a complete library of different type of locators, and you can create a complete character set and provide it to the rigger, so that instead of just a wireframe curve to operate your rig, they can see a solid shape which is not renderable, but it is similar to other shapes. And because it doesn't have a vertex information, it is a comparatively lighter node. And locators are very useful when they are used in the manipulators, which we will be seeing in the next volume of this training, which will be coming soon. So that's it for now. Thank you for watching the video. Bye.